6.2 is all about exponents and what we can do with them. So when we have an exponent, remember that is the number of times a number is used as a factor. So if we had something like 3 squared, we would have the number 3 as the factor, and it would be 2 times, which is 3 times 3. If we had 3 raised to the 3, 3 is used as a factor 3 times. So 3 times 3 times 3. And so 3 squared equals 9. 3 raised to the 3 is 27. 3 times 3 is 9, times 3 is 27. An important thing here is that you know that negative x squared does not equal negative x in parentheses squared. We talked about this before. This one means negative times x. This one is negative x times negative x. There is a big difference between the two. So some examples with numbers. Let's say that we have 3 raised to the 4. And when we have that, we could rewrite this as 3 times 3 times 3 times 3, and that will equal 81. If we have just something like 7 raised to the 1, that means that you're using 7 as a factor 1 time, so it just equals 7. And remember, anything raised to the 0 is going to equal 1. So some numbers, going back with the parentheses, let's say we have negative 2 all raised to the 3. That's going to be negative, or to the 3. So it's going to be negative 2 times negative 2 times negative 2. When we get that, we're going to get negative 8 as our answer, because we have 1, 2, 3 negatives, so that means our answer is going to be negative, and 2 times 2 times 2 is 8. Let's say though that we have negative 2 like this, raised to the 4. That's negative times 2 times 2 times 2 times 2. You'll probably see this one though as just negative 2 to the 4 like this. And again, that means negative 2 times 2 times 2 times 2. It's 2 multiplied by itself 4 times. Do not say 4 times 2 on this. So the answer to this first one, or to both of them, is going to be negative, because there's only one negative, and it's going to be 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now remember, with that example, it showed that the exponent only affects what's right in front of it. So let's say that we have 5 times 6 squared. The 2, the square, only affects the 6. It doesn't affect the 5. So if we were doing this in order of operations, we would do 6 squared, which is 36, and then times 5, which would equal 180. But if we do it like we just did, we could say 5 times 6 times 6. If we break it up, then we can do this in any order. And 5 times 6 is 30, times 6 is 180. It doesn't matter if you want to break it up, you can. If you don't, then remember to do the exponent first. Okay, then what about if we have a fraction? Say we have 3 over 4 squared. When we have that, it's the same as saying 3 squared over 4 squared, which is 3 times 3 over 4 times 4, which equals 9 over 16. So if you have a fraction and the whole thing is raised to a power, just everything in there is raised to the power, both the numerator and the denominator. Alright, so you're going to have a bunch of basic questions like this. Then you'll have some, say 4x squared, when x equals 3. Okay, so we're going to put 3 in for x. When we do this, put the number in parentheses every time. So 4 times 3 in parentheses squared. Okay, so this is 4 times 3 squared. 3 squared is 9, times 4 is 36. We could have broken this up, 4 times 3 times 3, and done it in any order. 4 times 3 is 12, times 3 is 36. Then let's say that we have x to the 4 over negative 8, where x equals negative 2. So remember, put this in parentheses. So it's negative 2 in parentheses raised to the 4 over negative 8. So this is negative 2 times negative 2 times negative 2 times negative 2 all over negative 8. So on this, we have negative 2 times negative 2, which is positive 4, times negative 2, which is negative 8, times negative 2, which is positive 16, still over negative 8, and our answer will be negative 2. Okay, so those are the basics. Now let's look at the product rule. This is something that you're going to see a lot. And just in general terms, for the product rule, it's if you have a to the m times a to the n. So what this is, we have the exact same number as the base, and it's multiplied by a number of the same base, and we have two exponents. And when we have that, we could rewrite it as a to the m plus n. So to make things easy, we could just add the exponents and then do the work. So to show you what that would be like, let's say that we have 3 to the 4 times 3 squared. Okay, so I'm going to do this two ways. First, I'm going to break it up into 3 times 3 times 3 times 3 times 3 times 3 and see what happens. And then I'm going to just work it out straight. So this would be 3 times 3 times 3 times 3. That would be 3 to the 4. And then times 3 times 3. Okay, so 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 times 3 is 9. And when we multiply 81 times 9, we're going to get 729. Okay, so that's when I just worked it all out. Let's say that we're going to add these two numbers, 4 plus 2. So let's go 3 to the 4 plus 2, and that equals 3 to the 6. We already saw here that we had 6 3's here that were all multiplied. So this will also equal 729. So you can do that either way. Mainly we're going to do this when we have x's involved. But let's do another number one. Say we have 4 times 4 squared. Remember that when we have 4 just by itself, we can assume the exponent of 1. So this is going to be 4 to the 1 plus 2 equals 4 to the 3, which equals 64. When there's no exponent, it's an implied 1. Remember to always do that. You're going to usually see that with x's. Okay, so, or y's, or whatever variable we have. So let's do something with both variables and number and coefficients. So 6 x to the 3 times negative 2 x to the 9. Okay, so on this, we're first going to multiply the coefficients. So 6 times negative 2 is negative 12, and we have x to the 3 plus 9. You don't need to worry about this negative in front. It's still going to be a plus here. So this is going to be negative 12x. 3 plus 9 is 12. So these are both x's, so we added the exponents. Let's say that we have m to the 5 n 10 times m n to the 8. Okay, so what I'm going to do is rewrite, I'm going to have the m's to each other. So here, we don't have any number here, so that means it's a 1. So we're going to have an m to the 5 plus 1 times n to the 10 plus 8, which equals m to the 6 plus n to the 18. Let me write that a little bit neater. N to the 18. Okay, so let's do another one that has some negatives. Let's say we have negative x to the 9 y times 4x squared y to the 11. Okay, so we have a negative 1 times 4, so that's a negative 4. X to the 9 plus 2, and y to the 1 plus 11. Now you don't have to write this step where you're adding them. Once you get better at these, you're just going to do it all just quickly. So here we still have a negative 4, x to the 11, y to the 12. Okay, so that is the product rule. Next, let's see what we do when we are adding numbers with exponents. So say we have 3x to the 4 plus 7x to the 4. This is just the same as we've done before. We're doing like terms. So we have the x to the 4 and x to the 4. So we can just add the 3 plus the 7, which is 10, and we have x to the 4s. So basically what this is saying is we have 3x to the 4s plus 7x to the 4s, and 3 plus 7 is 10x to the 4s. Let's say that we have 4x plus 3x squared. Here we have x to the 1 and x to the 2. We can't do anything, so this just equals 4x plus 3x squared. Okay, then let's say that we're multiplying some numbers. 7x squared times 3x to the 6. This is what we were just doing with the power rule. We're going to say 7 times 3, which is 21. And we have x to the 2 plus 6. So that equals 21x to the 8. Alright, so the next rule is the power rule. And I'm going to do it with a weird way first. So let's say that we have 2 to the 3 all raised to the 4. And so if we work out 2 to the 3, let's say that we're doing this as PEMDAS. So the first thing we would do is what's in parentheses. So 2 to the 3 equals 8, and it's raised to the 4. So this would be 8 times 8 times 8 times 8, which is 64 times 64, which is 16, 24, 25, 24, 36, 38, 4096. Okay, but let's say that we want to do the power rule. The power rule says that we can just multiply these two numbers, 3 times 4, and get 2 to the 12, which would be 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 2. Okay, when we do that, we have 4 times 4 times 4 times 4 times 4 times 4, which is 4 times 4 times 4 is 64, and 64, which is 4096. So we get the same thing. The power rule in general is if you have a raised to the m all raised to the n, we can rewrite that as a to the m times n. We keep the same base. So as a number, let's say 9 to the 4 raised to the 10, that's the same as saying 9 to the 4 times 10, which is 40. On the ones in the homework, you will have to work out like I did the previous one. Let's say that we have just letters, z to the 6 raised to the 3, that's z to the 6 times 3, which is z to the 18. Okay, let's look at power rules for products and quotients. Okay, so let's say that we have AB raised to the n. So A times B all raised to the n, that is going to equal A to the n times B to the n. So as an example, x, y raised to the 3, that's going to be x to the 3, y to the 3. One with numbers, 4x, the whole thing squared, it's going to be 4 squared times x squared, which is 16x squared. So you have to square or use the power on everything that's inside there. Now one thing that's a little bit different, that's when you're multiplying everything inside there. Let's say though that we have a plus b squared. We're not just going to say a squared plus b squared. It does not equal a squared plus b squared. So here's where this, if it was a times b, then you would say a squared times b squared. But if there's a plus in between, you don't do that. We'll see in a future section what you do when you have a binomial squared. But as a proof on this, I'm going to say 3 plus 4. And the whole thing squared, and it does not equal 3 squared plus 4 squared. So if we did this in PEMDAS, 3 plus 4 would be 7 squared. That does not equal 3 squared is 9 plus 4 squared is 16. 7 squared is 49, and 49 does not equal 25. This is going to be something that we see a lot later. And here's just showing you why you can't just square each part of it, each term. Okay, so let's do a little bit bigger one. Negative 3, a to the 4, d to the 8, all squared. So we're going to square everything here. I'm going to rewrite this as negative 3 squared, a to the 4 times 2, and d to the 8 times 2. Negative 3 squared, remember, is negative 3 times negative 3, so that's going to be positive 9. A to the 4 times 2 is to the 8, and B or D to the 8 times 2 is 16. So the answer here is 9, a to the 8, d to the 16. Okay, another one. Let's say we have negative 3, a squared, b, all raised to the 3. So this is negative 3 raised to the 3, a to the 2 times 3, and b to the 1 times 3. So here, negative 3 raised to the 3 is negative 3 times negative 3 times negative 3. We have 3 negatives, which is an odd number, so we know we're going to have a negative. And 3 times 3 times 3 is 27. We have a to the 2 times 3, which is a to the 6. And we have b to the 1 times 3, which is b to the 3. Okay, so let's say though that we have a fraction. We already knew what we did when we squared it. A over c all raised to the n. That we saw we would say a to the n over c to the n, and c here cannot equal 0. So we're just going to do whatever the exponent is to both parts of the fraction. So let's say that we have 3x to the 4 over 7y squared, and all of that is squared. So we're going to square every single thing in here. So that's 3 squared, and then x to the 4 times 2 over 7 squared, and y to the 2 times 2. So 3 squared is 9, x to the 4 times 2 is x to the 8, and here 7 squared is 49, y to the 2 times 2 is y to the 4, and in this situation y cannot equal 0.